Welcome back, everybody. So, little unboxing here at the beginning. I got an order from Aircraft Spruce, some foam, some flocks, and some micro. I also received an order from Amazon today with my West Systems 105, so I'm going to use all of that to close off the ends of some control surfaces here later on. But now, it's time to assemble the rest of the trim servo. I'd already prepped all those parts and primed them. I meticulously measured where those Z brackets go that hold it, and I did notice when I put it in that the control horn for the servo didn't line up 100% with the notch cut out for it. I questioned it, but I didn't go look it up online to see if anybody else had that problem or what the deal was. I just assumed that maybe it was slightly offset to clear the cotter pin that goes in there. It turns out everybody has that issue. If you put that exactly where Vans tells you to per the measurements, you're going to end up having to file out that opening to clear the clevis because it's not perfectly straight. Same thing with the back side of the trim actuator. It goes through a hole in the spar and it doesn't line up perfectly in the center. So my choices are I can leave it that way and just file it out, which is what I'm going to try and see how it looks. If I don't like it, I'm just going to order a new inspection plate and rebuild that part just to put it center. So when in doubt, if something looks weird, don't just assume that Vans made that measurement for a legitimate reason. There seems to be quite a bit of that in this kit where something, you assume that they did it for a reason, and then you find out that no, it's just the way it is and you got to fix it yourself. So anyhow, the trim all put together, or the servo all put together. I used some wire loom covering material there and some heat shrink just to cover up those wires so they don't get chafed on anything. Came out pretty good. There's the finished product. It's kind of hard to tell. I should have taken a picture straight on. You can see how far off it is, but that's it. I am going to change where the wires come out too. I saw somebody else make a hole in the lightning hole where the control horn is on the side and run their wires out that way, and I think I like that better than sharing the hole in the back where the trim actuator sticks out so the wires don't get chewed up. Right now, I'm also learning that when that thing's assembled, you have to be really good at puzzles to try and get it into the hole it's supposed to go into. It is just a little bit too wide, even if you try and slide one side in because of the angled front edges. It was a pain. I did ultimately get it in there, but it was just as hard getting it out, and I don't like that at all. This is a component I need to be able to take out, change, inspect, work on, whatever. I don't want it to fight. So I decided I'm going to make a little relief on the inside of that trim ring. Doesn't affect the nut plates that are in there or any part of the skin. It's just a little tiny notch on both sides to clear the front of that trim servo, and worked perfectly. Now it drops in and out just like I would expect it to. So now on to my least favorite thing ever in the history of anything with this build. I do not like rolling those edges. Can you tell? I've decided that the best method is still just using the PVC pipe and some vice grips. So there you saw me take the edge tool and I put a little slight bend in what's going to be my top edge, hopefully to get it to close up nice against the other edge when they're rolled together. I also decided I'm just going to go ahead and pre-drill the holes to number 30 now, rather than try and line them up later and drill them. This way, while it's open, I can still very easily drill the holes straight and deburr both sides. That is near impossible once they're rolled, so I figured I'd take my chances that the holes are going to line up, and if they don't, it's just a matter of more bending to make it work. So I started there on that outboard edge, that little flap, and I decided to do the top first and then the bottom. I do recommend, after everything I've done, doing the top edge first and rolling it until it is exactly where you want it to be, maybe just a little bit further, because rolling the second edge is way more difficult once the first one's in the way. So it's a whole lot easier to get the first one, what's going to be your top edge, lined up how you want it, and then get that second edge tucked in underneath it, and then that top edge will kind of help hold it in place, if that makes any sense. So the little flange went really well. That longer middle one is where I'm going to spend a lot of my time, whether I want to or not. You'll see me use that rubber mallet periodically. I'm not bashing on this in any way, shape, or form. It's just like little light taps to try and get a little tiny bit of movement one way or another, just to try and keep the center of that round right where I want it. So yeah, start of the middle one, and it seemed like it started well. I do need a second pair of channel locks though for doing some of this stuff. It would make life easier. Or sorry, vice grips. I use channel locks, but vice grips make it easier. So right there is where I kind of made the mistake. I had that one mostly where I wanted it. I think I gave it a little bit more bend and then I called it good, but it still wasn't perfectly flat like it should be. The edge where you're going to put the rivets. And then I went ahead to the other side. And I think that's where I made my mistake, because from that point on, once you do the second side, you're just fighting one side against the other, and it gets to be near impossible to get it exactly where you want it. And I'm not going to say, but I spent a lot of time on that middle section, and in the end, it still never fully came out the way I wanted it to. There's a little bit of pillowing between a couple of the rivets, but at this point, it's going to be what it's going to be. There's got to be a better way to do this, or I don't know. I even thought about earlier that, hindsight being what it is, it would have been a lot easier to roll these edges when the skin wasn't attached to anything, and then just deal with the rolled edges for the rest of the build until it was time to actually use them. But we'll never know. I know there's going to be more rolled edges on this project. In fact, I still have the rudder I got to do. I'd like to say it keeps getting better, but so far, no. So the inboard edge actually did go really well, but this is the part where I took the top edge and I didn't stop bending on it until I was 100% happy with exactly where it was before moving to the other edge. And then they ended up laying nice and flat. So the thing you didn't get to see on the other one is now it's time to rivet it together, and these are just the number 30 size pull rivets that they give you in the kit for it. I started out using the Milwaukee rivet gun, but it works so easily that it's hard to tell if it's really pulling the rivet enough. So I decided to just do a comparison between the hand riveter and the Milwaukee, and they're both pretty much the same. So I just kind of went back and forth with whatever one I decided to grab and use. The Milwaukee does seem to have an issue with jamming a whole lot. I've taken that thing apart a few times to get stems out of it, so jury's still out on whether that thing's worth it. At this point, I would definitely rather shoot solid rivets than blind rivets, as weird as that sounds. And if you stick around this far and to the end, the very end of this video does have what happened with the rapid potato relocation device. Yeah, so I'm thinking about making a lightning hole right in the middle of that control horn lightning hole there, and putting a grommet in it and having my wires come out the side there instead of the other end. I've seen that someplace else and it actually looked pretty good. But now it's time for testing. I have a 12-volt power supply on my bench there, and I was able to actuate it, but I wasn't satisfied with just watching it move. I want to watch it move the control surface. I'm not willing to shorten that rod yet, but I figure I can just clamp to it and get the gratification I want. So for the first time ever, one part of the plane is moving under its own sort of power. There you go. switch directions, you just swap polarity. Clamp slipped off, but you get the idea. It works. Thumbs up, pretty happy. So now I just got to put the hinges in, put the lock nuts on them. I think I need to get some crow's feet for those lock nuts too, because I can't figure any way to get in there and tighten those down otherwise. But there's a measurement on the plans, which is what I'm digging out now. I think it's 13/16 and then a max of 7/8. So I'm setting 13/16, and I'm using that little tool I 3D printed to run those down until the middle of the hole is 13/16. And that'll be my starting point for when I hang those very soon. All right, so there's the rapid potato relocation device that used to be mounted up on that pegboard on the very top. And you can see my horizontal stab precariously perched on a shelf right beneath all of those tools. In retrospect, not the best storage location. I never intended to keep it there longer than I had to, but it was the biggest place I had to keep that. It's going to get hung up here soon. But you can see the humidity here in Houston finally caused the pegboard to give in those spots. Not that the PVC was that heavy, but it fell off the hooks. And worst nightmare ever, right on top of the stab. Thankfully, it looks to be just superficial skin damage. More stuff to fix. Going to get those elevators hung and relocate it. But yeah, the rest of the tools look way scarier up there. So time to move that stuff. Anyhow, there's more of the damage. Hope you all enjoyed it. Don't make the same mistakes. I'll see you all in the next one.